We have the following sum or series and we want to analyze this. If I can use geometric series, then find R, then I can easily compare it with a geometric series. I have all the missing pieces. For a geometric series, the terms of the series were written as A plus AR plus AR squared plus AR cubed plus the rest of the terms, or summation of A R to power n minus 1 and start from 1 goes to infinity. And we saw that if the absolute value of R is less than 1, then you have a convergent sum or convergent series. This guy is A divided by 1 minus R. So our goal is to try to write this series in the form of a geometric series. We're going to do a little bit of algebra. By algebra, we are going to rewrite this series. So my series is the summation of 2 to power 2n times 3 to power 1 minus n, and start from 1 goes to infinity. This guy can be written as the summation of, so 2 to power 2n is 2 to power 2 to power n, and divided by 3 to power n minus 1. So my 3 was with power 1 minus n. I wrote it on the denominator and I have to use the opposite term. N still start at 1 and goes to infinity. But take a look. My numerator can be written as 4 to power n divided by my denominator is 3 to power n minus 1. So if I can create n minus 1, then I'm almost done. How do I create n minus 1 here? If I multiply and divide by a number like 4, then I can create that negative sign and start from 1 to infinity. This guy can be written as the summation of 4 to power n times 1/4 times 4 divided by 3 to power n minus 1, and start from 1 goes to infinity. But take a look, 1/4 is 4 to power -1. So this guy can be written as the summation of, keep 4, times 4 to power n times 4 to power -1 divided by 3 to power n minus 1, and start from 1 goes to infinity. Now that you have the same base, just write down 1/4 and add the exponents n minus 1. So we combine these two into 4 to power n minus 1, then divide it by the same quantity, 3 to power n minus 1, and start from 1 goes to infinity. Take a look at your geometric series. We are almost there. So this can be written as 4 times the summation of 4/3 to power n minus 1, and start from 1 goes to infinity. So what do we have here? If you write it in expanded form, you have 4 times 4/3 to power 1 minus 1 plus 4 times 4/3 to power 2 minus 1 plus the rest of the terms, which is basically a geometric sum. Or this guy can be written as 4 plus 4 times 4/3 plus 4 times 4/3 to the second plus the rest of the terms. Again, in geometric sum, you have A plus AR plus AR squared plus the rest of the terms. And as long as your R is bounded between 1 and -1, then the series is convergent to A over 1 minus R. But unfortunately for us, our R here is 4/3, which is more than 1, so the series is divergent. So this sum that we represented at the beginning, the summation of 2 to 2n times 3 to power 1 minus n, even though it's a geometric series, but it's a divergent geometric series. It means that if you add these terms together, it's not getting any smaller, it's getting larger and larger in size.